Hello, everyone, and welcome to our presentation today. We're going to be talking about cloud detection and response, as well as some of our latest innovations in Agentic AI and how that helps with cloud detection and response outcomes. I'm Karishma. I'm a product marketer at CrowdStrike. I've been here for about a little over a year. I've been focusing on cloud security for the past few years of my career. I started off as a penetration tester, and then I did what naturally comes next and moved into marketing. I'll hand it over to Ben to introduce himself.
Hey guys, my name is Ben. I've been in the space for about 10 years. I'm a senior technical marketing manager here at CrowdStrike. Been at CrowdStrike about 1 year. Worked previously at Palo Alto Networks and Cisco. Excited to present to you guys today.
Awesome, thank you. So I'm going to start off by painting a picture of what defenders are up against today. According to our latest global threat report, which released in February earlier this year, we found that the fastest breakout time was 51 seconds. Now, breakout time is the amount of time it takes an adversary to move laterally across a network. Now remember, when an adversary looks to gain an initial foothold into an environment, their next objective is to break out and move from where they are currently to where the high-value assets are. So what breakout time really determines for a defender is the speed at which a defender must move in order to drastically reduce the costs and damages which are associated with the breach. Now, if you're looking at the number right now, this is down from 2 minutes and 7 seconds from the year prior. So adversaries are only getting faster and faster. And if we're looking at less than a minute, right, this could be the amount of time it takes from grabbing your cup of coffee and sitting down, and an adversary can already be in there, escalating privileges and moving laterally. So let's talk about this adversary speed a little bit more. Adversaries move faster as a product of the strategies that they are looking to employ. These are some more notable trends that we found in our global threat report. The first one, I think, is really interesting. We found that there is a drastic increase, a 442% increase in voice phishing activity. Now, what does this tell us? This is very much aligned with the great advances that we've made in endpoint security, right? Adversaries are looking for the next best path or the path of least resistance for breaking in. And they're very much going after something we've been saying in the industry for a long time, which is that humans are the weakest link. And it's been surprisingly effective. We actually had a profile in our latest report on an adversary group, Curly Spider. And what they do is they actually pose as IT support staff, and they will call targeted users under the pretext of connectivity issues or security issues, and they gain access in that way. I know this is very real. I've been getting a lot of random texts from people who have been looking to help me, so it's weird how close you can get to these kinds of attacks. Second statistic on the slide is also aligned with the path of least resistance which adversaries are looking for. So we saw a 50% increase in access broker advertisements. What that tells us is that the access as a service market is booming. Now remember, an access broker is one who is looking to sell valid credentials on the dark web and facilitate in criminal activity. So again, if an adversary can get their hands on valid credentials and not trip any wires while they're executing on their operation, they will do so, right? And then lastly, when we're talking about initial access, CrowdStrike found that just a little over half of the vulnerabilities found were tied to initial access. So again, along with identity being a popular mode for initial access, vulnerabilities and misconfigurations are very much up there as well. Now, we talked about the breakout time, but this last trend is very, very interesting. So we found that almost 8 in 10 detections were malware-free. Malware-free essentially means that an adversary is engaging in a hands-on keyboard attack or an attack which is meant to blend in with legitimate user activity. And you'll get to see that a little bit later. Ben will be walking us through a demo. But what this tells us, and honestly, what every single trend on this slide tells us, is that adversaries are only honing their craft, becoming faster, and doing everything that they can to evade detection, right? And amplifying the problem even further is that AI has become a popular new addition to the global hacker toolbox. Even at this conference today, you guys have probably been seeing AI everywhere. Well, it's not just for the defenders, right? Adversaries can leverage it as well. And something that's interesting is that this relatively easy access to commercial large language models not only helps make adversaries more productive, right? It helps to shorten their learning curves and their development cycles, but also drastically increases the pace and the scale of their activity. An interesting statistic that we found around AI is that AI-generated phishing emails saw 4 times the success rate meaning and a victim clicks on the link in an email, than a human-generated phishing email. So this just goes to show that when AI is in the hands of the adversary, there's a lot of power there, right? Now that we've talked about the threat landscape at large, I want to talk specifically about cloud. This year alone, this calendar year alone, we've already seen a 45% increase in cloud intrusions, and this is compared to the entirety of 2024. Now, something interesting I want to note here is that back in 2023, there was a prolific e-crime adversary, Scattered Spider, and they were kind of the big dogs when it came to cloud intrusions. They made up for about almost a third of cloud-based intrusions. Now, that has gone down to about 13%, not necessarily due to decreased activity, but because there are new adversaries coming onto the scene, right? Like as you can see up here, Labyrinth Cholima is one of the newer cloud-conscious adversaries. Now, cloud-conscious means that an attacker is aware of the ability to compromise a cloud workload and leverages this knowledge to abuse features which are unique to the cloud. So right now, CrowdStrike has officially named about 7 cloud-conscious adversaries, and we're only seeing that number starting to grow. You'll see that in our reports, which will be coming out later this year. So adversaries are going after the cloud, but why? Why is it such a popular target? Well, as organizations are continuing to accelerate their adoption of the cloud, adversaries are following close behind. And the reason for that is because as your cloud footprint expands, right, a lot of the critical data starts to migrate that way, which means that there is now a much higher reward for attackers, higher value reward, if they are able to gain access to a cloud environment. On top of that, as we know, cloud spans multiple layers of complexity, right? And each of these layers come with their own unique risks. So now we're looking at this expanded attack surface. And when we kind of consider the high deployment velocity and the ephemeral nature of cloud resources, we not only have an expanded attack surface, but one which is in a constant state of flux. And all of this gives attackers just even more room to hide. And lastly, unlike traditional on-premise infrastructure, right, which is largely enclosed within defined boundaries, we have cloud activity, which is largely identity-driven. So you have users and services which are accessing resources from a variety of different locations, which makes things a lot harder to keep track of as well. So now we've talked about the threat landscape at large. We've also talked about why the cloud is a prime target. I am now going to hand things over to Ben, who's going to walk us through a real-world example.
All right, so progress the slide. Okay, cool. So just like Karishma was talking about, we're seeing a lot of malware-free attacks against AWS infrastructure and cloud footprints in general. So in this example, access keys were committed to Git repo commit history. Those keys were then stolen by an adversary. They had permissions to SSM. They leveraged those permissions in SSM to legitimately access EC2, opening up a reverse shell to command and control, and from there, further instructions were given, and ultimately lateral movement was achieved, and data was compromised from S3. Now, there's no malware in this attack. This is effectively like yourself taking your key to your house and leaving it underneath your doormat. If you don't take care of your keys and your credentials and have good, secure Git ops, this is what can happen. So just wanted to kind of throw a bone to you there, Krishna. This is an example of one of those malware free attacks here. So one of the things I want to walk through is like, how would this look like to investigate this kind of attack? You might want to first look at the access key exposure. Obviously, if you're committing access keys into Git repositories and not using, secure secret management, you're going to be wanting to at least look at the history of your commits. You're going to want to look at that IAM role that's associated with that key, right? What are the permissions associated, and what were the last used timestamps? From there, a next logical step might be to investigate any of the AWS API calls that transpired. A good place to look there would be CloudWatch or CloudTrail logging, and take a look at the GeoIP of those API calls. And the next thing, next logical step would actually look at that EC2 instance itself and provide forensics on that EC2. So things like session activity, what network sockets were open, any processes that were ran on that machine, and any subsequent behavior after that reverse shell was opened. Outbound traffic logs, et cetera, and so forth. To achieve that, the next step, lateral movement detection. This is one of the most challenging things to achieve from an investigation perspective. VPC flow logs can be helpful to look at that connection footprint, as well as investigating any network access control lists that have been updated, changes to security groups, and role assumption events. From there, obviously, S3 was impacted, data was compromised, so you're going to want to look at those S3 access logs, any data access patterns that might be anomalous, and do policy audits of those buckets themselves, right? Are they over-permissed? Are they, does this EC2 even need to be able to read from that bucket or write to that bucket, et cetera, and so forth. And then ultimately, with any investigation, you're going to want to do a timeline correlation. So it's important to understand the steps that the attacker or adversary took, and understanding how long the dwell time was. We see through our threat intelligence that some adversaries and e-crime actors are trying to achieve long-term persistence and live off the land as long as they can. So with that said, the goal is there to piece together different types of telemetry. Apologies on the on the overlap there. I swear it didn't look like that last week, but the two things I do want to highlight here is it's really coming down to two buckets, which I've broken down here, which is that service level logging, looking at those services themselves, the storage buckets, EBS volumes, identity and access management, and then also understanding what's going on the resource level, understanding what's actually happening on your containers, your Kubernetes clusters, and those machines as well. And that's kind of, in today's cloud tooling, it's a fragmented effort. And oftentimes, even in the most robust CNAPPs, it provides an incomplete picture. The two main buckets where you see these capabilities fall into is cloud workload protection and CSPM. Workload protection is going to be looking at those Kubernetes logs, runtime events, as well as anything that's been running on any container or workload. The other side of that coin is the CSPM side. So that's all about your proactive pruning of risk. That's going to be the ability to ingest those cloud logs, look at those misconfigurations. But ultimately, a lot of times, this information is displayed in different areas. It's hard to correlate, and it oftentimes lacks that correlated timeline-based investigation. Tools don't speak the same languages. There's limited context on cloud behaviors, and ultimately, too much noise and not enough signal. Back over to you, Krishna.
All right. So in order to address many of these gaps, this is kind of where Falcon Cloud Security comes in. We have something called Cloud Runtime Protection, and this includes both cloud workload protection and cloud detection and response capabilities. So again, that gap that Ben was speaking about, where you have visibility at the workload level, and then you also have visibility at the cloud control plane level, but there's this gap in correlation, right, and understanding the cloud context to activities that you might be seeing on the workload level. So that has really given rise to this new sort of category of solution, which is cloud detection and response. And that's something that we've been really focusing on here at CrowdStrike. There's a few things that I want to mention. First and foremost, I spoke a lot about this in the beginning, but Again, we are adversary focused, right? And I think that really is a compelling way to look at threat intelligence, because we're not just following CVEs or looking at threats on a generic level. We're really trying to understand who are the real world threat actors, what are their behaviors, and what are their motivations. Something really cool here actually is, I was speaking with our internal threat hunting team, and what they do is not only do they study what these adversaries have done already, right? How they have gotten from point A to point B, but also they try and map out even further what that adversary might do. How might they get from point A to point C or point D? And all of that kind of feeds into our detection logic, which is really cool. So speaking of our detection logic, that's kind of where our indicators of attack come in. So indicators of attack, those are early signals that an attack is currently unfolding, right? You kind of would like to know before an indicator of compromise might take place. And again, if you think back to that example which Ben showed, right, that was an attack that included a legitimate access key and legitimate tooling. So when it comes to cloud attacks, those look very different than what we're used to seeing on the endpoint. So what's really cool is that we've built out a repository of cloud-specific indicators of attack that look at that cloud control plane layer. On top of that, of course, we have our cloud runtime, our workload protection. So this is kind of monitoring and stopping breaches at runtime. But the last two points is something I really want to spend some time highlighting. So again, what's really important is the SOC experience as you're kind of investigating and responding to these attacks. Remember, adversaries are not limited to a specific domain, right? They don't just say, I'm going to attack just the cloud today. As you saw in the example earlier, they leverage an identity to pivot to the cloud. So attacks can span across endpoint, identity, and cloud, and the same should go for how we investigate and respond to these types of attacks. So we have unified graphs and event timelines which span across all domains in a hybrid cloud environment. And we also have built-in workflow capabilities which can help a defender to scale out a response no matter where that attack had originated from. So again, as I mentioned before, because we are so adversary focused, we continue to innovate by studying the threat landscape. And something that I mentioned also is that adversaries very much have AI at their disposal. And so what we want to do here is we want to make sure that we're leveling the playing field for defenders as well. So what we'll have next for you is a demo on how we are leveraging Charlotte AI to help with cloud detection and response outcomes.
All right, guys, if the demo gods smite me in front of you, just bear with me. So let me get my PowerPoint minimized here. Can we see my screen? Okay, cool. So, right, I want to first start off by kind of explaining the story behind what we're about to demonstrate here. And so what I got put together for you guys is kind of talking to our threat intelligence team. We came together and made an attack based off of similar TTPs that attackers have been using. So here's the story. We had a developer named Josh, junior developer, makes good money, doesn't make great money. He was a victim of a phishing attack that offered him a job. He applied via LinkedIn. They gave him a first interview, and then they gave him a coding challenge. That developer pulled down that Git repository repo, which had malware embedded in it. So when we completed the coding challenge, unfortunately, malware was deployed locally to his machine, and cloud credentials were scraped from his VS Code files locally stored. So don't be storing GitHub personal access tokens in insecure places. Those were compromised, and ultimately, the attacker was able to inject code into a Python function, opening up a reverse shell. From there, the attacker escalated permissions and then achieved lateral movement. So from there, we'll see in the attack, pulls down a variety of tooling, including AWS CLI, and then provides further persistence from there. There's a backdoor user that is created. We often see adversaries achieve persistence through creating new legitimate users and living off the land. And ultimately, this attack ends in data theft and data exfiltration. So I'm quickly just going to pull up the repository and kind of go through this user service that is compromised. So there was a demo beacon or a reverse shell beacon that was injected in the code base and is actually referenced in this user service. So what we're going to be looking at is a Kubernetes application that has a few different services running on them. One of them is going to be our user service. When that user service spins up, nested in the main function at the end of this script here, the demo beacon is opened, or that reverse shell is then opened. From there, command and control instructions are sent, and we will walk through kind of the exercise. So next thing I kind of want to show you guys, if I just do a git pods here and just show you what we're looking at, is kind of the architecture in which we're kind of defending this cluster with Valken. So what we're using is our Valken image analysis at runtime, our Kubernetes emission controller, and our Valken sensor that's running as a daemon set on this EKS cluster. So that's meaning we're defending each container running on this cluster, and we also have our ASPM relay and collector to provide that application context. And so what we were going to do really quick is kind of jump into the Valken platform and take a look at what we see. So we're kind of going to first do an investigation more from a manual perspective. We're going to kind of take a look at some different things. We're going to look at the process tree. We're going to kind of try to follow some of those steps that we mentioned before, try to get as much context and be realistic as possible as what a Cloud Defender would be going through. So we can see that we have this aggregated detection with adversary association with Labyrinth Chelima. The way that we make these associations typically is either from file hashes that we associate with malware with an adversary that we've observed, or bad known domains that we know are associated with adversaries. So when we click into this actual detection, we get a cool little picture of Labyrinth Chelima. Hopefully maybe some of you visited our booth and took a picture with them today. We'll just close the triage there real quick. But we get a wealth of information right here just to help defenders understand the adversary context, as Karishma was mentioning earlier. We can see this is a threat actor with origin from North Korea and is state-sponsored. We get a wealth of information around the process period of this particular command. We see that we are associating this initially just from this ping to this bad known domain. As we go down, though, we can see more information about the cloud asset. And I apologize, I'm kind of hovering over here. This desk isn't very tall, so I'm hunching over. But if we look really on this sidebar, we can provide the defender with a good amount of context. Hey, what account ID is this instance in? What region? What's the instance ID? You can open up the asset inventory and learn more. Not going to jump into that for this demonstration. We're focused on this detection piece. One of the other areas of information that we layer into the detection is actually the cloud misconfigurations that we've been observed with this EC2, and we can see there's a variety. It's 2025, and we do still see in the wild, I see some people smirking, instance metadata service v1. If you guys remember the Capital One breach in 2018, it's 2025. You may have some, you may have like a Uber dependency to use v1, but highly encourage you guys to audit your footprints and understand if you are using v1 in any of your environments. We see some other misconfigurations here that we flag. We call them indicators of misconfiguration. They're not necessarily indicators that you're under attack. It's just, hey, this default state that you have configured for this service, or in this instance, a EC2, could be improved. But ultimately, we will scan your cloud accounts and provide a readout of anything that we discover. And so when we see an attack against an EC2, we're going to automatically pull that cloud context down, as Karishma and I myself was talking about the correlation between endpoint and the cloud control plane. We also have a tab here for Kubernetes and containers. And since this attack is actually exploiting a vulnerable container, we can jump into the container details themselves. Open that up in a new tab here. And so from here, our Cloud Defender can now look into this particular container. So Fortunately, this details have expired for some reason. We'll push past that. I don't understand. I guess the gods have smited me this morning, but apologies for that. But typically, you will see container information. I think we had, because I'm looking at an event from 2 weeks ago, that information has timed out. What I want to do next is open up this full detection here and jump into the process tree. So when we look at the process tree, this is where we're going to be looking at all of the details around what actually ran on that container. And so we can see that Python user service.py is the parent process that opened up this reverse shell. So if we actually open up the reverse shell here, which is leveraging bash to provide the code execution, we can see a variety of commands here, pulling down additional tooling, as well as changing permissions, running netstat, typically to understand network connections, pulling down AWS CLI, and creating a backdoor user. From there, if we scroll in, we can see additional context from these AWS commands, ultimately resulting in theft of data from S3. One of the things I do want to also highlight here, as we're in this sidebar on this process tree, we can actually jump into context from the application. So we see the service owner, Josh, the gentleman that was a target of this particular attack, and he is the service owner. We provide that mapping for defenders. We can see that there's sensitive data associated with this service, and we give it a criticality risk rating. We can also jump into ASPM directly from this pivot. And we're filtered here on this user service. One of the things I like to do, and this is our ASPM product for you guys. A lot of people don't know that we actually have an ASPM product. Is from our acquisition of Bionic about a year ago. But I really like to use this data flow view. And this provides a context of all the upstream and downstream dependencies that this server has, or this service, excuse me. We can see all the APIs that it is talking to. So this provides a good deal of context. We've looked at what ran on the machine itself. We've looked at the misconfigurations associated with it. And now we've taken a look at some of the the application context. We can also, if we go back, we can investigate by looking at a host asset graph, which is easy to kind of visualize. So we're centered on the instance so this is the node of the Kubernetes cluster that this container ran on, and we can see all the images that are running on this container, as well as the permissions. So this is the actual role that was exploited, and the permissions that this role has. And you can see the variety of buckets that this role has access to. So this is helpful for defenders to gain that clear context of the broader impact of this attack. But as you can see, we provide a great deal of information on this side panel here. So just want to cover, we looked at the detection, we manually went through, looked at the asset graph, looked at information of the application context itself, and now what we're going to do is kind of shift gears and kind of take a look at what it would look like leveraging Charlotte. So one of the things that Charlotte can do that's actually kind of cool from this sidebar is we actually scroll up on this detection, we can see the reverse shell that was opened up, and we can actually have Charlotte analyze this reverse shell. And all she's doing is just taking a look at this particular command that was run on that container, and she'll provide a detailed readout providing context of the entire attack, or this command and details around this command. So we provide a nice little security evaluation and readout there. We also have the ability to have Charlotte do triage of detection. So she will automatically triage any detection that comes in. So she has said that we should escalate this and that it is a true positive and provides a nice verdict. So when this detection came in, this is her interpretation. So the detection was labeled as a true positive because of this process that ran, a reverse shell. If we look down, she provides further context of where that came from, and she knows that it was the parent process of that Python service that was running. So the next thing I want to focus on, as Krishna mentioned, the speed in which AI is moving, is how we can leverage workflows. So if we go into Fusion SOAR, which is our native security orchestration, I can show you guys a Charlotte workflow. Oop, that's not the correct one. Excuse me. This is the one. Okay, so what we've done here is set a trigger to say, hey, any alert that comes in, let's go ahead and trigger this action. So any alert that comes in, we're going to have Charlotte go ahead and triage that. The next thing that we're going to do is actually take the alert ID from that triage, and we're going to pass it to the next step. The next step is we're going to use ngSim, and what I will do is edit this so you guys can actually see what I'm doing here. And we're actually going to do an event query against ngSim using that alert ID from the previous step. And if we click into Manage Query, we can see what we're doing. So we're saying any event that comes in, grab that composite ID. We're going to enrich that information with the Kubernetes context. So all of the container ID information, all of the namespace, the nodes, et cetera, and so forth. We're going to pull that information in and join it. We're going to grab the APIs and then grab any indicators of attack. And then we're going to join on the actual sensor ID as well. Provide some context for Charlotte to rename things, make the naming convention a little bit cleaner, a little bit nicer, and then we're going to group the data. And so when that query runs, the next step in the chain here is Charlotte is actually going to use the Claude latest model, and she's going to be given this prompt. You are a tier 1 SOC analyst in charge of protecting a Kubernetes environment. You have received an alert from CrowdStrike Falcon in regards to one of your Kubernetes clusters. The data in this detection can be found below. And again, we're just using this variable and passing the results from the previous query here. This data consists of information about the cluster as well as detections from the cloud control plane that came from the same host node on that Kubernetes cluster. Some important information, region, cloud train detection rule, et cetera, and so forth. So we just provide her a nice little report, or a nice little prompt, excuse me, and then ask her to write an email. And so at the end of that phase, we say, hey, give us your triage verdict, your triage recommendation, your triage confidence, and your triage explanation. And at the end, what we do is we just, again, take the completion of that LLM call and then pass that as a variable for the email. And this is what it looks like. So when this detection ran on June 9th, at about, what time is it? Yeah, about 3:40 is when it ran. About 4 minutes later, we get this email. Security incident alert, Kubernetes cluster compromised. Hey, dear security team, we're writing you a report of a critical security incident detected in your Kubernetes environment. Our cloud Falcon platform has identified suspicious activity. Classified as command and control using remote access techniques. The detection revealed a reverse shell attempt from a container that subsequently used to create a new user and generate access keys via CLI in your AWS infrastructure, which are persistence techniques that adversaries use to maintain unauthorized access. And right here, this is awesome. We provide a ton of context. This is the affected resources. What pod was compromised? What was the image? Where is that image committed to? We can provide the full registry and path for that image. What namespace was that container in? What node was it running on? And what's the cluster ID? The next, she provides the triage details. The verdict is a true positive. What's the recommendation? What's the confidence? And what's the explanation? She says, hey, this was a detection that was labeled a true positive because the command line ran a bash process indicating a reverse shell. From there, the involvement of the Python processes as a grandparent of the process suggests that the initial compromise may have occurred through the Python-based application. So she can already tell, hey, there's something going on in that Python function. You guys need to take a look at it. which is very, very cool. Provide a source for the URL investigation, so you can click here and go right to that detection. And then she provides incident response recommendations. So I've already taken immediate action by terminating the comprised container to evict the adversary. However, this incident requires further investigation. Please revoke the access keys, delete any user accounts, audit the EKS node group role permissions, investigate the source image, review the network logs, implement network policies, and consider implementing runtime security controls. I recommend scheduling an incident review meeting to discuss with additional security measures from our Kubernetes environment to ensure we have fully contained this threat. So as you can see, we can use Charlotte AI and Fusion workflows to automate a lot of that tier 1 work. So that was my demo. Hope you guys enjoyed it. If you guys have any questions, I know Christian is about to go through a couple slides. I do just want to go back to endpoint detections and show you guys that we can actually provide those container details. And that's effectively where she's pulling those container details from. I'll just go with a detection that ran on cron last night. As this pulls up. And we can see all the data is here, the namespace, the region, what service and container. So when we query ngSim, this is where ngSim's pulling this information from. Hope you guys enjoyed it. Again, if you guys have any questions you guys want to ask at the end, feel free. If you guys want me to go through anything else, demonstrate anything else, ad hoc, I'm happy to guys sit down with any of you guys and deep dive into this stuff. But for now, I think it's time to go back over to Karishma, is that right? Looks good.
Yeah, thank you so much, Ben.
Yeah,
everyone give him a hand. That was a great demo. Awesome. So just a few slides, and then we'll have some time for questions. But I really wanted to double click into Agentic AI, which Ben brought up. I know you guys have probably been hearing about it around a lot, but there's just a few things I want to mention. So as I spoke about earlier, right, as organizations continue to expand their cloud footprints, threat volumes rise, and so do alert volumes, right? Because the cloud has a very dynamic nature to it. So you're looking at a much larger volume and variety of logs and alerts to have to sift through. So if you think about that, right, you have this sharp increase in threats and logs to sift through, but you don't necessarily have that increase in SOC team headcount or manual effort that's scaling linearly with that, right? And so what's really important to us as we continue to innovate with the Falcon platform is that we're doing what we can to help bend that labor curve so that you can continue to move with that same efficiency and speed, no matter how out of proportion these threats or the threat volume or the alert volume gets. And so that's been an interesting thing to kind of work on, is understand how to increase productivity as we're starting to see adversaries moving faster and faster. That's something that we spoke about earlier. Another thing is, right, cloud is a much newer thing to the scene. It's very complex, it's very nuanced, and there's not a lot of time to try and understand all of its complexities while you might be trying to investigate and respond to an attack. So that's kind of why bringing Agentic AI to cloud detection response outcomes was really an important effort for us. I do also want to speak a little bit on the difference between generative and agentic AI, especially because Charlotte AI can be both. She can do both if you need her to. So generative AI is when you have a very specific question or prompt that you want her to analyze, and that can come in handy, right? As we saw in the demo earlier, we wanted Charlotte AI to kind of pull the cloud control plane context and maybe query NextGenSim for specific things. But an AI agent is something that can complete a goal over time, and that is something that becomes increasingly important as it becomes harder to understand, if you get an alert, what exactly is happening, what is the scope, and what do you do next? So it's really cool that Charlotte AI can kind of guide you through that process and serve as a generative AI prompt along the way if you have specific things that you want from her or to ask her. I also want to speak a little bit about why we even can play in this AI space, right? I think everyone is doing so, but I want to speak a bit about what CrowdStrike has to offer. So when you're looking to stop breaches with AI, right, it's not just about the algorithms that you have in place, but it's about the data that you have to train it. And so what's really cool is that at CrowdStrike, we actually analyze trillions of security events a week, right? We have a large established customer base across the globe. We're monitoring everything that's happening, and we leverage that data to help improve our machine learning algorithms. Additionally, we have an adversary-focused threat intelligence practice, right? So our models don't just understand threats on a generic sense, but they're understanding adversary stories, what they're doing, how they're behaving, why they're doing what they're doing, and all that helps to make for a sharper understanding of threats. And lastly, I think this part's really cool. We actually built our agentic AI capability in strong collaboration with our managed detection response team. So these are expert analysts that have validated what our agentic AI capabilities are doing. And so we can kind of go out there with confidence that we're helping provide expert analyst support for any defenders that are using the Falcon platform. And then I'm just going to close out here by talking about how we have been recognized across the industry. I think everybody knows that CrowdStrike is an industry leader when it comes to endpoint and identity, but it's been really cool to kind of see us get recognized on the cloud side as well. As you can see, our cloud workload security or workload protection has been industry leading. We also have recently gained recognition in the CNAPP and cloud detection and response space. So definitely check out these analyst reports if you want to learn more about our capabilities and how we stack up. All right, that's it from us. Thank you all for attending.